you can hear me okay, please let me know by typing in the chat box. Okay, great, thanks for that. All right, so welcome to this Voltimum Webinar series. My name is Christian, and I'm co-presenting today with Alfonso. So I'm from Advanced Lighting. We were formerly known as Osram. We're the Osram lamp company effectively still. We're selling the Osram products. Alfonso Pozzo, he'll be presenting the second half of the webinar, and he is from iLighting. Today's webinar series is safety on LED lighting systems, and it's presented the leading information hub for Australian and electrical industry. Okay, so let's begin. So today, this is the content of the webinar. We'll be going through several things. I'll go through the first half, and then Alfonso will take over from the second half of this presentation. So I'll go through the details about changes in the risk classification, specifically for lighting products, new marking requirements, or just a refresher on the marking requirements concerning RCM, update to RESIS luminaire standards, the correct installation of LED tubes. Then Alfonso will take over and talk about SELV protection in LED lighting control gear, remote LED control gear, Inrush current and THD in LED luminaires. And finally finish up with the effect of blue LED lighting on humans and the environment. It's one of the American Medical Association reports that were published in 2016 concerning a bit of a concern with blue light. Okay, so by the way, if you've got any questions or comments, you can put it in the chat box. Depending on what the question is, we'll try to address it probably at the end of the presentation, so it doesn't delay the whole presentation. But if you've got anything, let us know, and we'll ask you again at the end anyway. Okay, so changes in the risk classification for lighting products. So risk classification for electrical products basically defined in the Australian New Zealand standard, which is called 4417 Part 2, 2012. There was a recent amendment where they basically have changed some risk classifications, and just for those who don't necessarily know, products are basically classified in three risks. Level 2 is medium risk and level 3 is high risk. Now, Fair Trading New South Wales it has a slightly different distinction with the risk classifications, because they've got basically things that they're not fully aligned with in relation to things concerning ERAC and so on, which I will talk a little bit about as well. But basically, they have very similar categories. Products are either declared article, basically a level 3 high risk product, or a non-declared, basically a level 1 or 2. A declared article or high risk basically means that a product must get mandatory compliance or safety certification. So you need a certificate of approval from either one of the state-based regulators as a supplier. The suppliers need to do this. With the non-declared articles, it's not actually mandatory to have a certificate of approval. If you voluntarily want to get an approval certificate, they call that a certificate of suitability for basically a non-declared or low-risk article. And I'll go into a bit more detail about what different articles are, or different level risk products are. Anyway, but that's the highlight here. So on the 14th of January 2017, basically is when these risk levels that they've reassigned for certain products will be reclassified. It's basically a year after the standard was updated and published. One of the main things that are affected, which I won't really be talking about much anyway, is building wiring cable, but that's obviously a big thing because it concerns lighting as well. So these have been moved into a high risk, so it'll be mandatory to get a certificate of approval for building cable wiring. And double cap light emitting semiconductor lamps, which are basically LED tubes, they are also being to high risk, so they'll also now be a declared article in New South Wales and therefore require a certificate of approval from one of the state-based regulators or one of the recognised authorised companies that can issue a certificate of approval or suitability. Simple portable luminaires are moving to level 2, so that's a slight difference as well. A simple portable luminaire is essentially something like a table lamp where you, in effect, got very basic componentry that makes it up. So a lamp socket, a lamp shade, and cable, and so on. The reason that that's relatively low risk is because certain components of that luminaire are already they already have level 3 high risk classification, as you'll see in the next slide. So, for example, lamp holder needs certification, the cable or sheath cable, and anything that's got plugs and even inline cord switches and so on need to have certification as well. Okay, so these other articles remain level 3 risk classification, so they're already there. And just so you know that these are all the lighting products that basically will remain high risk. So bayonet lamp holders, bayonet lamp holder adapters, decorative lighting outfits. Seems to be double up for some reason this. So that's decorative lighting outfits, Edison screw lamp holders, fluorescent lamp ballast, fluoro starters, specific portable luminaires, power supply or chargers, including LED drivers and therapeutic lamps. Just for the general understanding for everyone's benefit, the way that the classification system works is effectively if a general consumer can come into contact with a product and connect it and move it around like that, or has any can put a bulb into it or whatever, effectively item because a novice or general layman will come into contact with it, and therefore it's a high risk because there's risk of electrical shock. So, for example, a fixed luminaire such as a tropper or a downlight, a general user is not supposed to touch those things, and it's not portable, so they're supposed to be fixed in place. So they wouldn't normally be touching those, and therefore they're considered low risk, and therefore certification for safety is not mandatory. But that's basically the way that the risk levels work. Okay, so moving on to the regulatory compliance mark, the RCM. Basically, the RCM is now the important safety mark to signify compliance in Australia and New Zealand for both safety and also electromagnetic compatibility. Products that basically need to comply with it's got a switch of power supply in and have an EMC and a circuit that needs certification. Any product such as that would need to have the marking, if not for safety, then at least EMC. So if you have it, it basically signifies that it complies with one or the other, or the other, I should say. So since the 1st of March 2016, the 3-year transition period for suppliers to register on the ERAC National Database lapsed, basically. ERAC is basically Electrical Regulatory Authorities Council, and they try to basically bring all the state regulators together and harmonise and align things in all the Australian states, and including New Zealand, and harmonise standards and protocols that are basically rolled out in alignment with standards. The EESS is basically an online-based system where suppliers have to register to be a responsible supplier, and they also upload their certifications and documents for products that need to be updated on there, basically. So effectively, like I said before, all electrical equipment that require to meet EMC or safety should now be marked with the RCM. The old CTIC has been phased out since basically 2016. So some old legacy products may be sold through with it, but any products that are entering the market really now should have the RCM on there, and the CTIC basically has no longer any legal status. Okay, so moving on to the next topic, there's been some updates in standards as you've seen there, and one of the specific standards has been the recessed luminaire standard. So that standard specifically is called ASNZS, Australian New Zealand Standard 60598.2 Part 2, Section 2. That was published back in February this year. Basically, with the implementation of this, the updates in the standard, there's a 24-month transition period where the previous edition, which is the 2001 edition, will operate basically in parallel with the updated standard. So that effectively means it's basically grandfathering clause for any old luminaires and things that are and products that are out in the market to be able to be sold through and cleansed basically. And there, realistically, any new product should be following the new standard and the marking requirements that I will be touching upon in the next slide. So this standard specifically is addressing safety aspects of recessed luminaires. So a recessed luminaire could be a downlight, it could be a LED panel, which is basically recessed into a ceiling, fluorescent trophers, and so on. The biggest emphasis in the changes actually is to do with marking requirements in relation to installation classification. So that affects a lot of, especially domestic installations, because anywhere where there's insulation can be installed poses a potential fire safety hazard risk if you don't follow the recommended insulation classification, clearances, and so on. So all these updated changes will actually be cross-referenced in the soon-to-be published ASNZS 3000, the 2016 update, which is basically the wiring rules that everyone, if you're in the electrical industry, would be aware. It's basically the Bible of installing anything. So that's soon to be published and will cross-reference, as I said, the luminaire standard and the requirements for marking, particularly with recessed luminaires and the insulation classification, so that you know what product to put into what sort of situation. So moving into the specific categorizations of products. So the first one we've got is called a non-IC luminaire. Basically, this is a recessed luminaire that cannot be abutted against or covered by normally flammable materials or used in installations where insulation or debris is or may be present in normal use. So basically that really restricts it for commercial and industrial use only. You cannot use it in residential because there's always a risk, even if there is no insulation, that there will be some thermal insulation at some stage, because that's the commonplace thing for residential applications. The other thing with non-IC luminaires is that they may not have actually been adequately tested for use for building insulation, so therefore that's the risk factor there. You'll see the little symbol there. Basically, it looks like a downlight can, but that's the symbol that from now or within that 2-year transition period will be required to be marked on a luminaire if it's an IC type luminaire. Sorry, a non-IC type luminaire. So the next type is identified as a do not cover luminaire. So basically it's a luminaire, a recessed luminaire that can be used where normally flammable materials, including building insulation, are or may be present, but cannot be abutted against any material and cannot be covered in normal use. So it's not self-explanatory. You can't cover it and you can't put combustible materials right up against it. These are basically not suitable for residential use in New Zealand as per ASNZS 3000, the wiring rules, but they are suitable for commercial use and residential use in Australia because there's slight variances there within ASNZS 3000. However, if you're using this luminaire, you must observe the stated clearances from the sides of the luminaire and the insulation and clearances above the luminaire. So I mean, think about the old halogen downlights. You could use them within a 200 mil clearance around the downlight from thermal insulation. It's kind of in that same vein. The the stated clearance obviously has to come from the manufacturer, so that would have been tested for, and basically it needs to come with the product. If it doesn't come with adequate instructions, then an electrical contractor will not be able to basically install it in a safe manner. So that is actually legally required to come with the product, and that's the symbol down there. So actually a big cross over the insulation in the pictogram there. Okay, so we've also got another classification called CA90 luminaire. This is a recessed luminaire that can be abutted against normally flammable materials, including building insulation, but cannot be used. But cannot be completely covered in normal use. Building elements, building insulation or debris have limited access to heated parts of the luminaire, and that's just a probe test that they do to make sure no parts can get inside. This classification is suitable for residential or commercial in both Australia and New Zealand. So effectively it means you can have insulation right up to the luminaire touching it, but you can never at any point cover it. The 90 denotes that the external surfaces of the luminaire will not basically go above 90 degrees, so it's not considered to be a fire hazard. It's been tested to comply with that recommended temperature rating. So that's both Australia and New Zealand. I didn't include a slide for another classification here because it doesn't really apply to Australia, but there's also a CA135 rated luminaire, which is a New Zealand specific requirement. So the only difference there being that A, it's only enforced and usable in New Zealand, and B, the luminaire surface temperature has a slightly higher rating, and that's for instances where you can have it insulation that can withstand up to 150 degrees Celsius touching the luminaire. So it's slightly different regulations for Australia and New Zealand on that CA90 versus CA135. Okay, so the next one is an IC luminaire. Basically, an IC luminaire is a recessed luminaire that can be abutted against normally flammable materials, including building insulation, and can be covered in normal use. So building elements, building insulation or debris have limited access to heated parts. Basically, again, it's a probe test to make sure that heated parts can't be accessed easily. But effectively, an IC luminaire is suitable for residential or commercial use. It basically can be used in areas where some air transfer is allowed or desired between a living space and a roof space. So maybe a gimbal fitting has some, gaps in the luminaire, for example, that allow some air to pass through. So that might be an example of an IC luminaire with an adjustable gimbal. IC4, so previously it was called ICF, but it's being updated to IC4. It's basically the highest specification for insulation, button and covering. Basically, it's a recessed luminaire that can be abutted against normally flammable materials, including building insulation, and can also be covered in normal use. Building elements, building insulation, debris, etc. It's restricted access to the heated part of the luminaire, and that's basically tested again by a small probe to make sure that those elements cannot get inside the luminaire. That's just the test that they do. These are again suitable for residential and commercial applications, and it's probably the most common type of downlight you'll find in the market that would be used across residential applications, because it's more or less a cover-all. If you don't know if there's going to be insulation or if there already is insulation, then this basically will be your default sort of go-to. Let's say currently, like I said, it's called ICF, IC-F, and the new reference will be called IC4, and it will have this pictogram at the bottom with the IC-4 above it. These are used where air transfer not permitted or not between a living space and the roof. So again, a sealed downlight where there's no gimbal adjustment won't allow air to pass through from the room to the ceiling cavity anyway. So that's what that means. Okay, there is one classification which is kind of a non-classification, but basically a recessed luminaire with no marking. So basically, if the luminaire is not marked, a recessed luminaire that is, then it means it hasn't been tested to be compliant to the Australian or New Zealand standard. If it's not marked, it by default means it's actually not compliant. So if you're an installing contractor, you shouldn't be installing this luminaire basically, because it's not been tested, it's not marked. We don't know what sort of scenario you can use it in. It's not been safe. Okay, so moving on to the next discussion point, and that's to do with the correct installation of LED tubes, basically T8 double cap style tubes, which are relatively common in the market now. The current standard that defines the requirements for these LED tubes is actually AS/NZS 60598 Part 2, Part 1, 2014 Appendix A. For those of you that actually recognise the standard number, it's actually a luminaire standard, part of the luminaire standard. And what they've done is they've put in an appendix, which, because one part of it addresses LED luminaires that are made to take these LED tubes, but the other part is specifically in the appendix, which addresses the standards for LED tubes in Australia and New Zealand. So with this standard, there's basically two types of tubes that are currently allowed. One's called a type A, and you can see by the little diagram there that basically one end of the tube has the live and active and the neutral. The opposite end needs to be electrically bridged, so it's got an internal bridge there. So basically there's complete electrical isolation from one end of the tube to the other, so you can't get an electric shock. Say if you insert one end of the tube and the other tube's not in properly, you can't get a zap from the pins. That's basically why they've designated that there needs to be either this type or type B. Type B is constructed in a similar way, but basically the one end's got the active and the neutral. The opposite end has basically the lamp cap pins have to be electrically isolated from each other, so there's no through wiring or anything like that coming through. Having said that, type B lamps, as per the standard, will actually no longer be permitted after 16th of May 2017. So that's fast approaching. From my experience, I think most products tend to be type A. Tubes need to be marked which type they are anyway if they're on the market. So if they're not marked, you probably shouldn't be using it. And then there's also a series of other requirements such as input voltage, wattage, ambient temperature range, and so on that need to be present either on the packaging or on the tube itself to be able to identify. But the type A, type B should be on the rating label of the product. LED tubes need to come with instructions also that explain in what scenarios they can be used. So LED tubes also need to be supplied with warning stickers just in case there are situations where an electrical contractor may need to modify the internal wiring of a luminaire. An example of that is if there's a fitting with a balance, you cannot operate type A tubes, for example, on airflow gas. They're only compatible with the magnetic ones and the starter. So if the contractor wanted to on there, rewire the fitting with direct 240, they could potentially do that. And I'll go into a bit more detail on the next slide on that. But basically, the instructions need to be provided for how the alternate methods can be done. And the warning sticker needs to be in the packaging, as I've mentioned, as per that little box I've got there. So warning, for example, not for use with any fluorescent lamp, for use only with type A or type B tubes. So that needs to be put in a prominent place inside the luminaire so that if there's a future relamp, people don't inadvertently put a fluorescent tube back in and blow it up. Because once you modify a luminaire, it's wired to 240, it won't run with a fluorescent lamp anymore. So going back to type A tubes specifically being the more common and the one that us in the Osram brand have available, these are designed basically primarily really as a retrofit for existing fluorescent installations with magnetic ballasts and starters. So the starter is basically a fuse that needs to replace the fluorescent starter and it completes the circuit. So the tube can be replaced very simply by taking out the fluoro, putting in the LED and changing the starter, and it can operate. However, some luminaires come ready directly wired with 240 volt. These type A tubes also work directly to 240 volt if an electrical contractor were to rewire a luminaire, for example, to bypass and get rid of an electronic ballast. However, having said that, as per the standard, the luminaire needs to have a 250 volt, 2 amp, max HRC fast acting fuse. And that needs to be somewhere in the luminaire. If there's not a starter holder, then it needs to be maybe in, the terminal block somewhere as part of the circuit, as per the little diagrams down there. So the left-hand side of the magnetic ballast circuit, and the left there is if you were to wire the tube direct onto 40 volts. I mean, any wiring that's done obviously needs to be done by qualified or licensed electricians. So it's not something that anyone should be doing. It's important to also note that if a contractor does modify the wiring of a luminaire, the luminaire manufacturer can't be held responsible anymore for any compliance of that luminaire because it's been changed, it's been altered, so it's now effectively a new luminaire. So that's one of the risks in doing that. And that's it from me. So now I'll pass on to Alfonso, who will talk about SELV drivers.
If you can hear me. Hopefully you. Thank you, Christian. Thank you, Christian. Well, my name is Alfonso from Highlighting, and I'm going to present this second part of the safety on LED lighting presentation. And I will start with SELV, which well you might have seen in some power supplies, electrical equipment. SELV stands for safety extra low voltage, and these are circuits, can be power supplies, electrical equipment with safe isolation. ELV, according to Australian New Zealand standard 60598, means the voltage which does not exceed 50 volts AC or 120 volts DC ripple free between conductors or between any conductor and air. Also, apart from ELV, extra low voltage, just safe isolation is in these products refers to the isolation between primary circuit, which is basically AC mains, and secondary side, which is the output voltage. And for example, it can be used in an isolation transformer. The secondary circuit has no direct connection with the primary side, and under any faulty condition, it derives its power via the isolation transformer, converter, or any equivalent protection system that it might have. So protection ensures that the output voltage remains below the voltage value at any time, allowing for safer luminaires and reducing the danger of electrical shock. And this is basically specified in international IEC 61140. However, even the briefest contact with this safety extra low voltage, which is said before 50 volts AC, 120 DC, this might have serious consequences to a person's health and safety. So SELV devices provide a special insulation to parts conducting mains voltage, and it constitutes safe isolation. Many switch mode power supplies, which we'll see later on, they can be basically all of them AC to DC converters, basically included in any LED light, LED luminaire. They meet the SELV requirements, and they usually also include overvoltage protection features that disconnect power supply before reaching the maximum allowed output voltage. As an example, I include a picture of a basic low power LED driver. And well, moving on to basically a definition of LED drivers and power supplies. They are one of the most important critical parts of an LED luminaire. They supply the adequate DC power to run LED modules, supplying forward voltage and the forward current. There are main classification. There are two types of LED drivers. Constant current, they supply, the name says, constant current, value of direct current, and to the LED modules. They are the most common and versatile types. And then there are constant voltage, and they supply a fixed value of forward voltage, here usually 12 or 24 volts DC. And they are generally more efficient than constant current, but on the other hand, more sensitive to temperature changes. Sometimes LED systems require mounting the power supplies remotely, separate, and connecting the LED module separate apart from the LED driver. Whether if it's for thermal reasons or accessibility, maintenance of control gear, or reducing weight, there are many reasons. And anyone can think that it's as simple as extending or using longer cables, but there are several factors that must be considered beforehand. First of all, the type of LED driver that the luminaire is using. And as just explained before, is it a constant current or a constant voltage? Well, constant voltage drivers have a limitation in the maximum distance because there's always a voltage drop across the wires, the positive and the negative output of the driver. And the DC voltage of the module, which is at the other end of the cable, can be lower than the voltage at the output of the driver. And operating those LED chips at lower voltage have adverse consequences and can lead to a lower light output and a premature failure of the LEDs. In the case of constant current drivers, the LED module do not suffer the impact of voltage drop, but the driver might operate at higher stress, increasing the output voltage to counteract the losses in the longer wire. So that might increase the temperature in the operation and as well might cause some issues on the LED driver. The size of the cables is also another important characteristic to consider. This is also related to the previous point, what type of it's constant current or constant voltage, and especially being constant voltage refers to the voltage drop in the wires. And sizes of the cables is dependent on the length of that cables and also the cross section or diameter of those cables. Electromagnetic interference, it's EMI. This is the key point here. And LED luminaires must comply with EMC standards and ensure any interference introduced in the surrounding environment remains below established limits. Usually lead wires in and out of the LED drivers are the most troublesome as they can behave as antennas emitting radio frequency noise. And prolonging the wires between drivers and LED modules might increase the risk of electromagnetic interference. Also, the type and category of cables is important. They are shielded and twisted, and type of protection also for electromagnetic interference. So in itself, an LED driver or power supply for this is considered by Australian authorities a high-risk product, level 3, or a declared article in terms of electrical safety. So modifying an LED luminaire. It's permitted by the original equipment manufacturer. Is in such a way that the driver is withdrawn or removed from the inside of the luminaire and connected remotely. It might require new EMC testing and compliance with EMC standards, and in that case, this case for lighting refers to standard Australian and New Zealand standard SPR15. So if remote mounting of the LED driver or drivers is necessary to be carried out, always refer to the manufacturer of the luminaire to see in this case if it's possible and the consideration or requirements to follow in order to comply with regulations. And obviously, as we always say, ensure that this type of jobs are carried out by professional electricians. Well, now moving on to inrush current, which is another issue important with LED lighting. First of all, a bit of a definition of inrush current. It's also known as starting current. Is the maximum amount of instantaneous AC current drawn by an electrical or electronic device. And the best example in this case for us is a power supply or LED driver, LED lighting. And this inrush current it happens basically when power is first applied, and inrush current is greater than normal operating current of the equipment. They are found in all types of lighting application, not only in LEDs, but can be even in incandescent lamps and magnetic, electromagnetic, magnetic high intensity discharge lamps and control gear. LED luminaires need power supplies to operate, obviously, the drivers, and these drivers contain switch mode power supplies, which are electronic circuits, most commonly with large capacitors, and these capacitors can charge very quickly when drawing large amounts of current when first switching on after a certain time of inactivity, so what is usually called cold start. Inrush can be easily 50 to 100 times the normal operating current of the equipment when power is applied, and it lasts for sorry. And as I was saying, it can easily be 50 to 100 times the normal operating current, and it lasts for a few seconds, depending on the supply voltage, the wiring used, several other factors. Just as a quick example, a typical 80-watt fixture can easily exceed the 60 amps peak inrush current. So inrush current is a parameter that must be provided by the original OEM of LED drivers, power supplies equipment, and it is generally given this parameter as a maximum because it's not a fixed value. Inrush varies, can change depending on the exact moment of the AC waveform in which power is applied or switched on. So as you can see in the graph attached, the blue line refers to the mains voltage, and depending on the moment of the switching on, which is the green line, inrush current changes. So as I show in this slide, there is a big difference in the inrush current depending on the moment. So this graph shows as an example, the difference in the inrush current of a 60-watt LED driver, constant current, and when power is applied at the peak of the AC waveform, and when power is applied at 0 volts. There's a big difference between 47 amps starting the power supply and 6.5 amps when voltage is when power is applied at 0 volts crossing. You can also see that there is a damping effect on the following cycles of the current, which is the red line, but it very quickly stabilizes to the normal run current of this 60-watt drive, which is 0.5 amps. The main question here is inrush current a problem? And well, definitely it can be, and especially critical when upgrading lighting installations to energy-saving systems such as LED. Basically, circuit breakers are installed to protect any electrical circuit. They must have the capacity to protect the load that is connected to, and in our case, lighting installations. So when upgrading or replacing lights with LED might not create protection issues in households or domestic use, but most likely in office and industrial buildings if the installation is not designed or analyzed properly. The main cause is tripping circuit breakers. Also, the more LED fixtures connected together to the same switch protected under a single circuit breaker, the higher the inrush current. And because this value of this inrush is accumulative, so having n number of LED luminaires increases the total current passes through the circuit breaker, causing obviously tripping. The duration of the inrush, as said before, is very short, just a few milliseconds, but it can trigger a circuit breaker if the current reaches the maximum tolerable value of the breaker, the circuit breaker. So when replacing your lighting installation with new LEDs, LED light fixtures, ensure the electricians take into consideration the inrush current and also the number of fittings connected in the same circuit, and make sure also that redesign and they include, if necessary, adequate circuit breakers with adequate capacity to safely protect and run the entire load connected light fittings. Well, there are new technologies being developed to mitigate the starting inrush current of power supplies, and one of the most common famous is called zero crossing technology, which is a simple circuit. It contains a switch connected at the input of primary side of the driver, and it detects when the AC waveform passes through zero, which in a 50 Hz system is every 0.01 seconds. And whenever power is applied to the load, the zero crossing circuit is capable to delay the switching until the sine wave goes to zero, very close to 0 volts, and start supplying current. So it's the same example as I was showing before. This ensures a minimum inrush current value, as you could see in the example of the 60-watt driver, and obviously when connecting several fittings in series together to a same circuit breaker, makes a big difference in the total inrush current that a circuit breaker allows. Some LED drivers and power supplies already include this technology, which is built in inside the drivers, but also some sensors and smart technology accessories, they are starting to integrate them as well, and they're especially important when a large number of bits are connected together in the same circuit. This can be the case of street lighting. And also to finalize the presentation, just to mention as part of the safety on LED lights, I have to mention the report released by the American Medical Association, the AMA, in June this year regarding the effect of blue LED light on human health and environment. The statement they basically explain two main problems, and especially on street lighting, new street lighting with LED. First point is discomfort and glare. LED lights are very concentrated and contain a high amount of blue light, and it can cause severe glare and even damage on the eye and cause problems in clearly for safe driving and even walking at night. The other issue that the AMA was raising was the impact on human circadian rhythm that could lead to serious health consequences. And it's this melatonin is a hormone in animals and some plants, regulates sleep and wakefulness. And melatonin suppression has been found that is a marker in circadian disruption, and an LED light is 5 times more effective at suppressing melatonin at night than the high pressure sodium lamp. So the AMA in this statement also recommends to minimize and control the emission of blue light, obviously outdoors, especially in street lighting, reduce glare, shielding, provide shields for fixtures, minimize the glare, and use warmer color temperatures in outdoors installations, especially 3000 Kelvin or even lower, typical color temperatures of high pressure sodium lamps, the one that we usually see at night on roadways, and not possible dimming it during the off-peak periods. This has been so far. There has been so far quite a few responses to this AMA report from industrial and lighting associations, and in the graph below, I just as an example, I just include what is called an spectral power distribution, a white LED, and is mainly the relative irradiance of each wavelength of the visible band in a light source. In our case, it's a LED, and you can see the big amount of blue light component around the 450 nanometers of wavelength. It's a big amount of blue light. That's basically all about the presentation on safety. Thank you all, and does anyone have any question regarding our presentation today?
Just for everyone that's online, there'll be a short poll at the end. If you could participate and just give us some feedback, that'd be very much appreciated. We'll still stay on a little bit longer to see if there's any questions. If there's not, we'll wrap it up.
Well, thank you, Christian. Thank you, Atmat. Thank you all for attending the presentation, the webinar. It's much appreciated.
Okay, thanks for everyone for joining us, and appreciate joining on this webinar series. And again, just a reminder, when this webinar finishes, we'd appreciate if you could just quickly fill in the short poll just about feedback on how you thought this webinar went. Thanks very much, and goodbye.
Thank you. Bye-bye.